First of all, thanks for being here in my YouTube channel. So in this lesson number 3 on the topic time and distance, we are going to solve 7 different questions that is based on the concept called late, early and also usual time or otherwise usual speed. So first 6 questions will be on the concept called late and early, and the last question the small concept that is based on usual time or otherwise usual speed. So remember that before watching this video, don't forget to watch all my previous video, that is lesson number 1 introduction about time and distance, and in lesson number 2 we have solved some of the question, basic level question. So only after watching both the lesson kindly watch this lesson number 3, or otherwise you can't able to understand anything, right? And before solving all the question in this lesson, first you need to know that all the question that is based on this late and early concept you can solve by a normal method or otherwise you can solve by a formula method, right? So a normal method is basically that was followed in our textbooks or otherwise some foreign author books. If you have any aptitude textbooks, I'm just going to solve all the question by a normal method and also by a formula method. But remember that 100% of the question, all the question can be easily solved by applying a formula method, right? So remember that the formula is D is equal to del T into S1 into S2 divided by S1 difference S2, where S determines the speed and D will be the distance and del T will be the time difference. So while solving the question I can say how to find the value of del T, but remember the formula. Distance is equal to time difference into speed 1 into speed 2 divided by speed 1 difference speed 2. Got it? And another important thing is the time chart, right? So everyone has to know this time chart. Only for the first question, listen carefully, only for the first question out of 7 questions, only for the first question I'm going to draw the time chart, right? So time chart is why I'm drawing the time chart is just to understand the concept, right? This is a shortcut, right? Instead of drawing a time chart you can directly say by using this shortcut, but anyway for question number 1 alone I'm going to use by a normal traditional method and without using this shortcut, right? From question number 2 we can directly apply this shortcut. So remember that if it is a late and early or otherwise early and late, add the timings, right? So add the timings. And if it is late and late, early and early, then subtract the timings. So friends, got it. This is just a small shortcut, right? Remember this, if late and early or otherwise early and late, while seeing a question I can explain this, but remember that if it is late early or early and late, then you need to add both the timings. If it is late and early, so you need to subtract the timings, right? First question alone, let me solve the question by normal time chart, and also I will explain you the traditional method. So from question number 2 I can directly apply this shortcut, right? So friends, now let me move on to all the 7 questions. Again I'm saying after watching this video you try to practice more than 10 or 20 questions based upon this pattern. Only then you can able to understand the concept 100%. Question number 1. A man goes to his office by scooter at a speed of 30 km per hour and reaches 6 minutes earlier. If he goes at a speed of 24 km per hour, he reaches 5 minutes late. The distance of his office is. So friends, understood the question? So what they are saying, a man, he is going to his office by a scooter and initially his speed was 30 km per hour. If he runs a scooter is 30 km per hour, then he is reaching the office 6 minutes earlier. And the second condition, in case if he is at a speed of 24 km per hour, then he is reaching the office 5 minutes late. So first speed is early and the second speed is late. So only this question comes under the logic called late and early. So remember that our target to find what is the distance from his home to the office, right? They are not talking about from where he is moving. So let me fix from home to the office, our target to find what is the distance. So listen carefully, this time chart is not at all required for the experts, only for the beginners I am drawing this, right? Important. And listen carefully, let me fix some timing, right? The man usually go to the office at 10 o'clock, right? We are fixing some timing, it can be 9 o'clock or it can be 8 o'clock, whatever be, but just fix some timing. This was the usually he used to go to the office. A man usually go to the office at 10 o'clock. Now his speed is 30 km per hour. So first speed he is 30 km per hour. and now he is reaching the office 6 minutes early. So we can say that he will reach the office at 9:54. Friends, got the logic? Listen carefully. Most important, we are fixing a timing as 10 o'clock is the usual time he used to go to the office, and if his speed is 30 km/h, he reaches 6 minutes early. From the usual time, he is reaching 6 minutes early. So we can say that he will reach the office at 9:54. And the second case, if the scooter speed is 24 km/h, he is reaching the office 5 minutes late. If it is 5 minutes late, then he will reach the office at 10:05. It's 5 minutes late, 6 minutes early. First condition, 6 minutes early, he is running at a speed of 30 km/h. And 5 minutes late, then he will reach the office at 10:05 and the speed is 24 km/h. So listen carefully. Here we have 6 minutes, right? Got it? From this 10 o'clock, here we have 6 minutes and here we have 5 minutes. The total time difference between both the cases is 11 minutes. So friends, understood? This is only we are saying most important. Listen carefully. We have fixed the timing as 10 o'clock. And first case where he reached the office at 9:54. And the second case he is 5 minutes late. So the total time difference from the first case and the second case, the total time difference, here we have 6 minutes and here 5 minutes. The total difference is 11 minutes. So we can say that first time and the second time, the difference is 11 minutes. So we can say that time 1 and the time 2 difference is 11 minutes. So this is what we call it as a time chart. So if you solve more questions, this is not required. Again and again saying, this is not at all required to solve this question. Just for the beginners I am saying, right? By just seeing a textbook, some students will have a doubt that how did they put this 11 minutes? That's what I have explained this, right? So time difference between both the time is 11 minutes. So what is the formula for time? Speed is equal to distance by time. Time equal to distance divided by speed. So distance divided by speed, difference distance divided by speed is equals to 11 minutes. Remember that distance is common, right? So let we keep it as d as it is. And the speed, initially it goes at a speed of 30 km/h. So 30 km/h. Difference, which is minus, and the second d divided by second speed, 24 km/h is equals to 11 minutes. So after writing this, look at the options: 20 km, 21 km, 22 km. All the options are in kilometers, but here we have in kilometer and also in hour, and here we have some terms in minutes. So what is our target? Our target to cancel hour and a minute. So let me do one thing. We can convert the 11 minute into hours. Conversion of minutes into hours divided by 60. So finally 11 divided by 60 hour. Now you can cancel hour and hour. So finally we have converted the complete term in terms of kilometers. So now I think we can take LCM, or 120 can be an LCM, right? So once you take 120 LCM, so 4 3s are, that is 4D, minus of this will be 5 times. So 5D is equals to 11 divided by 60. You can cancel 60 2 times. It is a difference, right? So difference 5D 4D, the difference will be D. So D is equals to 11 into 2 kilometer. So finally distance is equal to 22 kilometer. So we found the distance from his home to his office is 22 km. Got it? You should not write this as minus D because we are talking about the difference, right? So 5D, 4D, difference will be D. So D divided by 2 is equal to 11. We already know the denominator value we have in kilometers. So 11 into 2 will be 22 km. So finally answer for question number 1 is 22 km. Now the same question can be solved by using a formula also. Now we can solve this question by a formula method, right? What is the formula? D is equals to del T into S1 into S2 divided by S1 difference S2. And I have already told you that del T is the time difference, and we know the time difference is 11 minutes. So we can say that D is equals to 11 in order to convert the minute into hour. So 11 divided by 60, S1 and S2. S1 will be 30. S2 will be 24 and S1 difference S2. 30 and 24, the difference is 6. So into 60. Got it, friends? S1 difference S2, 30, 24 difference is 6. and first speed is 30 km, second speed is 24 km. Del t is the time difference that we calculated initially is 11 minutes. In order to convert the minute into hour, so 11 divided by 60, and now you can cancel this 32 times 1 2s are 2, this becomes 12 times 1 6 are 6, 6 2s are 12. So finally we have denominator 1 and the numerator 2 into 11, so which is 22 km, right? This looks like easy. This is easy, right? So finally we can say the answer for question number 1. The distance of his office is 22 km. Question number 2. Walking at 5 km per hour, a student reaches his school from his house 15 minutes early, and walking at 3 km per hour, and he is late by 9 minutes. What is the distance between his school and his house? So friends, I have told you initially we are going to solve only the first question by a normal traditional method. After that, instead of drawing the time chart, we can directly say what is the time difference, right? So the question that is based on early and also late. Initially is 15 minutes early, and the next is how much minute late? 9 minutes late. So it is based on the concept called a late and early. So if it is late and early, what I have told you, you need to add the timing, right? So 15 minutes and 9 minutes, when you add both the minutes, the resultant will be 24 minutes. So finally we can say that the time difference will be 24 minutes. If you want a time chart, I can draw this also, right? Let me assume that the student exact time is 8 o'clock in the morning. Usually he used to reach the school in 8 o'clock in the morning, and now his speed is 5 km per hour. If he goes at a speed of 5 km per hour, he reaches the school 15 minutes early. Then we can say that he will reach the school at 7:45. So before 15 minutes from the original time, he reaches the school. And if its speed is 3 km per hour, he reaching the school at 9 minutes late. So definitely we can say that he will reach the school 9 minutes late, that is 8-9. Now the time difference between both the timing will be 22 minutes. So got it, 45, here we have 15 minutes, 9 minutes, the time difference is 22 minutes. So this is not required, but anyway learn this also, right? So finally we can say that the time difference will be 24 minutes. So now we can say the time difference, time 1, difference time 2 will be 24 minutes. Time will be distance. So time difference, time is equal to distance divided by speed, and the distance is common. Speed will be 5 km per hour. So 5 km per hour, and the difference second d divided by the second speed, which is 3 km per hour. So 3 km per hour is equal to 24 minutes. In order to convert the minutes to hours, why? Because all the given options are only in kilometers. So our target to eliminate the hours. So let me convert the minute into hour, which is divided by 60. Now we can say that the right hand side term is in hours and also left hand side term is in hour. So we can cancel this hour and also hour. So now I think we can take an LCM as 15 kilometers. So once you take 15, 3, and this will be 5. So 5 and 3, the numerator will be 2d. So finally got it, friends, or otherwise I can do this. So 5 into 3 will be 15. So 3d difference, 5 into 3 will be 15. So 5d is equals to 24 divided by 60. So you can cancel this 15 4 times will be 60, and once you cancel this 1 4s are 4, 6 4s are 24. So 5d, 3d, the difference will be around 2d. So 2d is equal to 6, so d equal to 3. So finally we can say that, or otherwise I can solve this. 5d, 3d, the difference will be 2d is equals to 6, so d equal to 3 km. So finally we can say that answer for question number 2 is 3 km. So let me solve this question by a formula method also. Next is formula method, and you know the formula, d is equals to del t into speed 1 into speed 2 divided by speed 1 difference speed 2. So d is equals to del t is the time difference. We got the time difference, that is 24 minutes. So 24 minutes, in order to convert the minute into hour, so let me divide this by 60. Next is speed 1, speed 2. Speed 1 is 5, speed 2 is 3. And next is difference. 5 and 3, the difference is 2. So now you can cancel this. So I think 1 5s are 5. This will be 12. So 12 2s are 24. You can directly cancel this 24. So finally we have only 3 remaining. So we can say that distance is 3 km. So answer for question number 2 is 3 km. Question number 3. A student rides on bicycle at 8 km per hour and reaches the school 2.5 minutes late. The next day he increased the speed to listen carefully, increase the speed to. So the word to is most important, that I've told you in the basics, right? There is a difference between increase the speed to and increase the speed by. So remember that, most important. And this is based on increase his speed to 10 km per hour and reaches the school 5 minutes early. How far is the school from his house? So our target to find what is the distance between school and the house. And what all the data they have given. Initially, first speed, he is 2.5 minutes late, and the second speed, he is 5 minutes early. What is the concept? The concept is based on late and early. So if it is a late and early, what you need to do? You need to add both the timings. The first timing is 2.5 minutes and the second late early is 5 minutes. So once you add both the timing, it will be 7.5 minutes. So finally we can say that the time difference will be 7.5 minutes. So initially we can solve this question by a normal method. So time 1 difference time 2 is equals to 7.5 minutes. So time will be distance divided by speed. So distance divided by first speed will be 8 km per hour. So 8 difference and the second time divided by, and the second speed, he increase the speed to 10 km per hour. Increase the speed to 10 km. So now he is running at the speed of 10 km per hour is equals to 7.5. So let me convert the 7.5 in hours, which is 7.5 divided by 60. So next is d divided by 8. So let me take an LCM. So once you take an LCM as 80, this will be 10d difference, this will be 8d is equals to 7.5 divided by 60. This can be written as 75 divided by 600 for the easy multiplication, right? So 10d, 8d, the difference will be 2d. So 2d divided by 80 is equals to 75 divided by 600. Now you can cancel this 800, and similarly you can cancel this on I think we can directly cancel 7 and 8 times. You can directly cancel 75 8 times, and you can cancel this on 10 times. So 1 5 times. So d equal to 5 km. So finally we can say that answer for this question, the distance is 5 km. So friends, got it how I have did this, or otherwise I can do again. See here, 10d 8d will be 2d. So 2d divided by 80 is equals to 75 divided by 600, right? So what I actually did, I have cancelled directly in 8 times. 8 5s are 40, so we can say that 60. So we can directly cancel this 8 times, and 80 and 10 times, and 1 2s are 2 5 times. So d equal to 5 km. So answer for this question number 3, the distance from his home and the school is 5 km. Now we can solve this question in a formula method also. Next is formula method. You know the time difference is 7.5 minutes. So distance is equal to del t into S1 into S2 divided by S1 difference S2. So del t will be 7.5 minutes. So 7.5 divided by 60. S1 S2, the first speed is 8 km and the second speed is 10 km. The difference will be 2 km. So first is 8 and the second is 10. So now you can easily cancel this. I think you can cancel 1 10s are 10. So 10 6 are 60. Again you can cancel this on 2 table. 1 2s are 2. 4 2s are 8. Again you can cancel this on 2 table. 2 2s are 4. 3 2s are 6. And you can cancel this on 3 table, which is 2.5. So once you cancel this on 2.5, then 2.5 into 2 will be 5 km. So distance will be 5 km. This is by a formula method. So finally in both the methods we got the distance from his home and the school will be 5 km. Question number 4. When a person cycled at 10 km per hour, he arrived at his office 6 minutes late. He arrived 6 minutes early when he increased the speed by 2 km per hour. The distance of his office from the starting place. Similarly, our target to find the difference, and most important word here, increased speed by. So word by always important. Remember that previous question, increase the speed to. So we have directly taken 10 kilometers, and here he is increasing the speed by 2 kilometers. From the previous speed we have to add 2 kilometers for the second speed. Got it? So, and this question is based on late and early. So again it is late and early concept. So if it is a late and early concept, you need to add both the timings. 6 minutes late and 6 minutes early. So 6 minutes plus 6 minutes then 12 minutes. So time difference will be 12 minutes. So time 1 difference time 2 is equals to 12 minutes, and the time 1 will be distance divided by speed. Initially speed is 10 km per hour, difference d divided by, and the second speed he increased the speed by 2 km per hour. So we need to add this 2 km per hour to the previous speed, that is 10, and 2 will be 12 km per hour, is equals to 12 divided by 60 in order to convert the minutes to hours. Now you can cancel this directly 5 times here, because 1 divided by 5 will be 60. So I think 12 and 10 we can directly take LCM as 120. So this will be 12d difference 10d is equals to 1 divided by 5. And now 12d 10d will be 2d. So 2d divided by 120 is equal to 1 divided by 5. So 1 2s are 2, 60. So d is equals to 60 divided by 5. So d is equals to 12 kilometer. So finally answer for this question number 4 is 12 kilometer. The important concept in the question is increased by. Right, in the previous question it is increased to. Now we can solve this question by a formula method. So d is equal to del t into s1 into s2 divided by s1 difference s2. So del t, the time difference will be 12 minutes, so 12 divided by 60. S1 will be 10 km and s2 will be 12 km, so 10 and 12, and the difference is 2. So now I think we can directly cancel 10 6 times, 1 6 are 6, 6 2s are 12, cancel 2 and 2. So finally we got the distance is equal to 12 kilometer. So answer for question number 4, the distance between the starting point and his office is 12 kilometer. Question number 5, a boy walking at a speed of 20 kilometer per hour and reaches his school 30 minutes late. Next time he increased by 4 km per hour, still he is late by 10 minutes. So our target to find what is the distance between the house and the school. So listen carefully, all the previous 4 question is based on the concept called late and early, but this question is based on the concept called late and again it is late. So what I have told you in the beginning, if it is late and early, add the timing. If it is late and late, then you need to find the difference on the timing, right? Or otherwise you can subtract both the timings. Just see here, initially his speed is 20 km per hour and he is late by 30 minutes. So first late 30 minutes. And the second time, even he increased the speed by 4 km per hour, still he is late by 10 minutes. So again he is late by 10 minutes. So this concept is called late and late. If it is late and early, we have added in all the previous case. Now it is late and late, subtract both the minutes. So once you subtract this, time difference is 20 minutes. So we can say that time 1 difference time 2 will be 20 minutes. So time will be distance divided by speed. So after that the same logic, right? So distance divided by speed, and the first speed is 20 km per hour. Difference time 2 divided by speed, and he is increased the speed by, listen carefully, the word by is important. Increase the speed by 4 km per hour, which is we need to add the 4 km per hour to the original speed. So 20 plus 4 will be 24 km is equals to 20 divided by 60. So I think we can take an LCM as 120. So once you take LCM 120 here, so this will be 6 times, so 6d, this will be 5 times 5d, so difference 5d is equals to 20 divided by 60. So you can cancel this 3 times, and again you can cancel this 4 times, which is 40. So 6d 5d will be d, so d divided by 40 is equals to 1, so d equal to 40 kilometer. So finally answer for this question number 5, the distance is 40 kilometer, right? Got it, friends? So all the previous question late and early or early and late, so we have added, but in this case it is late and late, so we need to subtract both the timings. Similarly, if it is early and early, again you need to subtract the timings. Now we can solve this question by a formula method. So d is equals to del t into s1 into s2 divided by s1 difference s2. So d is equals to del t, and the time difference is 20 minutes, so 20 divided by 60, and s1 and s2, speed first is 20 and the speed second is 24, so 20 and 24, and the difference is 4. So now you can cancel 20 times here, 3 times here, Similarly, 1 4 3s are 12, 12 2s are 24. So 20 into 2 will be 40 kilometer. So in both the methods, we got an answer from the distance between the school and the house is 40 kilometer. Question number 6. If a car runs at 40 km per hour, it reaches its destination late by 11 minutes. But if it runs at 50 km per hour, it is late by 5 minutes only. The correct time in minute for the car to complete the journey is. And it's completely different, right? Why? Because all the 5 questions we have found what is the distance. But in this question, our target to find what is the correct time to reach the destination. Right? Interesting question. So if our target to find that time, first we can find what is the distance from the starting point to the destination. If we find the distance, then finding the time is easy. So let me do one thing, whether this question is based on the concept called late early or late and late. Listen here. First, the speed is 40 km, he was 11 minutes late. And the second, the speed is 50 km per hour, again he is 5 minutes late. So we can say that this concept is a late and a late. And if it is late and late, we need to subtract the speed. So initially 11 minutes and 5 minutes, so difference will be 6 minutes. So we can say that the time difference is 6 minutes. Now I think for finding the distance, we can go with the formula method, right? So formula D is equals to del T, which is 6 minutes divided by 60. And the first speed is 40 and the second speed is 50. So 40 into 50 and the time difference, speed difference is 10. So now you can cancel this 10 times here. 1 tens are 10, 10 fours are 40. So we can cancel this 5 times. So 5 into 4 will be 20 kilometer. So friends, we have found the distance from the starting to the end is 20 kilometer. But our target to find what is the correct time. Listen carefully. We can take any one condition. We can take the first condition. If the car runs at 40 kilometer per hour, right? They have given a speed here. And the time taken is 11 minutes late, right? So 11 minutes late. So let me do one thing. Without using this 11 minutes late, let me find what is the time taken to reach this distance, right? So the speed is 40 km and the distance is 20 km. Listen carefully. For 1 hour, the car speed is 40 km. Our target to find only 20 km. If it is 1 hour 40 km, what about 20 km? The car will take only 30 minutes. So 30 minutes, if the car runs in this speed, it will take only 30 minutes to reach this 20 km. But they have given the question that if the car is running at a speed of 40 km per hour, it is late by 11 minutes. So we can subtract this 11 minutes. So finally we can say that the correct timing to reach the destination is 19 minutes. Understood the logic, right? So how I have solved this question. So finally answer for this question is 19 minutes. So what they have given that if the car is running at 40 km per hour, it is 11 minutes late, right? So we can say that the distance is 20 km. We have found the starting to the ending, the distance is 20 km. If car runs at 1 hour 40 km, then half an hour will be 30 minutes. So it takes only 30 minutes to reach the destination. But if the car runs at 40, it is late by 11 minutes. So we need to subtract this 11 minutes. So the actual time to reach the destination is only 19 minutes. But because of car speed is 40, it reached by 11 minutes late. So only we have subtracted this 11 minutes. So finally answer, the correct time to reach the destination is 19 minutes. Question number 7. Walking 6/7 of usual speed, a man is 12 minutes late. The usual time taken by him to cover the distances. So friends, listen carefully. The question is completely different. So walking 6/7 of the usual speed. From the usual speed, he is walking 6/7 of the speed. So that his timing is 12 minutes late to reach the destination. And what is our target? Our target to find what is the usual time taken. Our target to find the time taken, but the given value is speed, right? From the usual speed is walking only 6/7 of the usual speed. So listen carefully. Before solving this question, let me understand some concept. So remember that speed is always inversely proportional to time. That everyone knows it, or otherwise I can explain you by few examples. Listen here, the distance from the starting point, let me assume this is starting point and ending point. So distance between starting point and ending point is 100 kilometer. And we are running at a speed of 10 kilometer per hour. So how many hours it will take to reach the destination normally? If we are running 1 hour 10 kilometer, our target to cover 100 kilometer, how many hours it will take? 10 hours. Totally 10 hours we will take to reach the destination. In case if we increase the speed by 20 km per hour, now the speed is 20 km per hour. Think that we are running a speed of 20 km per hour. How much hour it will take to reach the destination? It takes only 5 hours. So when we increase the speed, the time decreases. So got it first, this is the actual speed and the actual time taken, but when we increase the speed and the time gets reduced. So only we are saying whenever the speed is increased, then the time will be decreased. If we run faster to the destination, then we will reach in a less number of time. So only we are saying that speed is inversely proportional to time. Whenever the speed increases, the time decreases. So our target to find what is the usual timing. Listen carefully. So listen here, this is a late timing and the usual timing, right? So late timing is 12 minutes late, right? So late timing difference usual timing will be 12 minutes. So friends, got it? In the previous question they have given two different timings. So we have found whether it is late early or late and late. But here they have given only one timing, that 12 minutes late. So from the usual timing, when you subtract the late timing, so we can say that the difference between the late time and the usual time will be 12 minutes. So now let me do one thing. Here usual time, let me keep it as x. And listen carefully, the late time they have given 6/7 of the usual speed, but our target to put a value here in terms of time. If it is 6/7 of the usual speed, then the time will be inversely proportional, which is 7/6. Got it? Speed is inversely proportional to time. If the speed is 6/7, then the time will be 7/6. So we can say that x into 7/6. So 7/6 of the usual time. Important, listen carefully. If the speed is 6/7 of the original speed, that is usual speed, then the usual timing will be 7/6 of the usual time. So 7/6 of the usual time, that is x, is equals to 12 minutes. So now we can subtract this. 7x divided by 6 minus x is equal to 12 minutes, because it's a difference, right? Difference is subtraction. So 7x minus 6x divided by 6 is equal to 12 minutes. So finally 7x will be, x is equals to 12 into 6 will be 72 minutes. But look at the options are in hours, right? So better we can convert the 72 minutes can be written as 60 minutes plus 12 minutes. And 60 minutes will be 1 hour. So 1 hour 12 minutes. So finally answer for this question is 1 hour 12 minutes. So friends, got it? So most important logic, and everyone know this, right? But remember that speed is always inversely proportional to time, and they have given 6/7 of the usual speed, and the timing will be 7/6 of the usual time. Got it? Inversely proportional. So friends, finally in this video we have solved some of the question that is based on late and early, and also usual time, that is based upon this question. So make your books, practice more and more number of questions. Only then you can able to understand the concept more and more. So thank you so much for watching this video, and if you really like it, share this video to your friends so that your friends can also learn this. So thank you so much for watching this video. Bye.